Hi guys, good night everybody. Just let me know if you guys can hear me before I start, please. All right, guys. So good night everybody. Welcome to my last and final session before the CSEC Maths Paper 2 exam, right? I just want to wish everybody good luck in that exam tomorrow, right? Um, Read your questions carefully, right? By now, you should know the format of the exam paper. There are 10 questions which are compulsory, right? You have to do all of them. There are no choices in the paper, right? Question one, we know is going to be based on numeracy. So you might get a fraction question, a decimal question, standard form, decimal places, significant figures, right? So that's the first part of question one typically. In question one, two, we will get a question on consumer arithmetic, right? With respect to consumer arithmetic, we have things like simple interest, compound interest, we have profit, we have loss, we have a lot of things that can come there actually. We have profit, we have loss, we have appreciation, we have depreciation, we have rates considering bills, right? Water rates, electricity rates, all of those things can come in question one, including things like wages and taxes and all of those things. That's in question one. In question two, we know that we're going to get a whole question based on algebra, right? So question two, the entire question is based on algebra. So that is things like factorization, simplification of algebraic expressions, changing the subject of the formula, direct and indirect variation, right? Simultaneous equations. All of those things can come in your second question, right? The third question in the exam is based on geometry. And when I say based on geometry, we can have things like you could get a question on Pythagoras' theorem in question three, but you will also get transformations in that question. So things like translation, reflection, rotation, enlargement. That is your third question in the exam paper, right? Question four is based on functions. So you may get a simple question on functions, right? And that could be finding the inverse of a function, substituting something into a function, composite functions, right? In that question also we could get things like gradient of a line, equation of a line, parallel lines, perpendicular lines, right? So that's question four. Question five is usually based on statistics. So when I say statistics, we need to understand things like mean, mode, median, right? We could get a cumulative frequency curve, but I have my doubts on if we're going to get one of that tomorrow. We need to know histogram, frequency polygon, line graphs. All of those things fall under statistics, right? That's question, where did I reach? Question five. Question six is based on measurement, and there are some students who have difficulty with measurement. Not all the formulas are given to you for that particular question. So you need to know some formulas. Things like volume of a cylinder, area of a trapezium, area of a square, volume of a sphere. All of those things you need to know that for that question. That's question five. I'm sorry, question six. Question seven is going to be based on our investigation type question, right? And that question is where we might be given some diagrams and we have to figure out what the pattern is when it comes to these diagrams. That's question seven. Usually pretty straightforward if you kind of know what you're doing. So that's question seven. Question eight is going to be based on relations, functions, and graphs. So you could get in that question to draw a quadratic. We could be asked to complete the square, right? We could also be given a question on linear programming. That can also come there in question 8, right? And question 9 is based on geometry and trigonometry. So we're definitely going to get a question on circle geometry. Every year we get one. We will probably get a question on bearings, right? In which case we have to use the sine rule and our cosine rule more than likely in a question like that. And the final The final question, question 10, is based on vectors and matrices, right? And this is typically, this is nothing new that I'm telling you guys here. This is known, right? Based on the format of the exam, this is known. This is nothing new, right? So what I'm going to be doing today, I'm going to be going through a sample exam paper here, right? One of my sample exams here, right? So before, guys, just remember to please hit like and subscribe, right? Please remember to hit like and subscribe. You can share the link for this class if you want, right? I normally do have online classes. My new Form 4 classes will start in August, right? So let's start. So question 1, right? Using a calculator or otherwise, we want to get the exact value of this here, right? Now, a piece of advice to you guys here. You see they said using a calculator or otherwise, forget the otherwise, right? If they tell us go ahead and use a calculator, please do so to work out the question. So what I will do in a question like this here, I'll work out the numerator first. So that's 4 and 3 over 10, right? Minus 1 and 1 over 5, right? So that's 3 and 1/10. So the top part here is going to be 3 and 1 over 10. And we're dividing that now by 1.5. So divide by 1 second. Let me just reset this. Right, so I just had to do something here on my calculator, and that's something you should do before you go into the exam as well, right? Make sure that you reset your calculator just before you do this exam, right? I just had to reset my calculator because it had some craziness on it. So please reset your calculator, right? Okay, so let me do this over again, right? So 4 and 3 over 10, right? Minus 1 and 1 over 5. And you're going to get 3 and 1/10, right? And we're dividing this by 1.5. Right? And you're going to get 2 and 1/15, or we can leave that as, right? Right, so 2 and 1/15, or you can leave that as 31 over 15, right? So any one of them will be acceptable, right? I want to get a chance to check the chat, right, guys? So just for your knowledge, right? Just for your knowledge, this is not the paper that is coming tomorrow, right? I know sometimes I get ridiculous questions like that, right? This is not the paper that is coming tomorrow. This is one of my papers, right? I have not seen the paper. I have no idea what's going to be there, right? So that is part 1. Part 2, we want to work this out here. So we have a question involving decimals, and we want our answer to 2 decimal places. Again, you're going to use your calculator in order to do that. And what we're going to do, we're going to use our order of operations, which is BODMAS. So we always work out brackets first. So this is 1.65 multiplied by 0.59, right? And then we're going to add that to 0.125 squared. 1.65 multiplied by 0.59 plus 0.125, right? Just double check my answers as well. Sometimes when you work in some of these things, you can make a mistake very easily. So what I'm getting on the calculator is 0.989125, right? That's what I'm getting on the calculator. However, the question says they want their answer to 2 decimal places. Pay attention to this in your real exam, right? So we want our answer to 2 decimal places. So this answer should be 0.99, right? So 2 decimal places, that's what we're going to put as our answer, right? Right, I see everybody put in 1, right? But they said 2 decimal places, right? 2 decimal places would be 0.99, all right? All right, this next one here, Adrian bought 63 t-shirts at a costing $80 each. He then sold all at his store for a total price of $75.60. calculate the total price Adrian, right, paid for the t-shirts. So this is typically what happens. So if somebody has a store, they will buy from abroad, and usually they buy in bulk, so they save some money there. So the total price Adrian paid for the t-shirts, he bought 63 of them, so that's going to be 63 multiplied by the cost. He paid $80 for each. Right, so that's going to be 63 multiplied by 80, and he paid $5,040, 5040. So that's how much he paid for the t-shirts, right? Calculate the price Adrian sold the t-shirts for, right? Now the thing is, in the question it says he sold all the t-shirts, right, for a price of $75.60. So if you want to work out the price of one t-shirt, we're going to take $75.60 and you're going to divide by the 63 to figure out the cost for one t-shirt, right? So in this case here, it's going to be 7560 divided by 63, and you're going to get $120, right? So that's typically what happens if somebody wants to make a profit. Remember, he paid $80 and he's selling it for $120. The next part here, we want to calculate Adrian's profit, right? What is his profit? Now, the thing is, he paid a total of 5040, right? And he sold them for $75.60. So his profit is simply going to be the $75.60, right, minus the amount he paid for it, which is the 5040, right? So that's going to be $75.60 minus 5040, and he's making a profit of $25.20, right? $25.20, right? So that's the profit that he's making there. The part 4 says calculate Adrian's profit as a percentage of the cost price, right? So you want to work out percentage profit. So percentage profit, all right, is simply equal to whatever profit he made, which is $25.20, right? You're going to divide that by the cost price, right, which is how much he paid for the original price he paid for this thing here, which is $75.60. Sorry, not $75.60. Is it? No. The amount he paid for the t-shirt was $5040. So that's his cost price, right? $5040, right? Multiplied by 100%, right? So when I work this out here, multiplied by 100%, right? He's making a profit of 50%. Let's let me know if I'm making sense, right? Right, people getting 50%, right? Great, right? So it's always good to have feedback, right? I know sometimes when I post some videos which are not live, right, there may be some errors. Once you don't have people giving you feedback, it's very easy to slip, right? So I do apologize for some questions where I might have some small errors, right? But what you could do is to kind of thank me for the 99% of the times that I have the questions correct, right? Somehow people tend to identify the errors and say, hey, sir, you make a mistake, right? So yes, I do agree there are some mistakes in some of the questions, right? So just keep that in mind. Right, so that's part B. Part C now, a carton of juice, right, contains orange, grapefruit, pineapple, and kiwi. The ratio of juices mixed in the carton are, so orange to grapefruit to pineapple to kiwi is 9 to 4 to 7 to 5. The carton contains 250 mLs of, mLs is milliliters, this is milliliters here, of kiwi juice, right? The first part says calculate the total volume of juice in the carton in liters. Now, this is a ratio question, right? And whenever I give you a ratio, what you should do is to first figure out how many parts do we have here, right? How many parts do I have here? So in this case here, we have 9 and 7 is 16, 16 and 4 is 20, so we have 25 parts, right? You add up the numbers you see in the ratio, and that gives you the total number of equal parts, right? Now, we're looking at the kiwi juice, and it told us kiwi is 250 mils. So which part of the ratio is the kiwi? So the kiwi is this 5 here, right? So basically, this part 1. So 5 parts, right? 5 parts of this juice is made up of kiwi, and we know it's 250 milliliters, right? Now you want to figure out what is the total volume of juice. So we're talking about the whole 25 parts here now, right? So basically 25 parts, right? So if you know 5 parts is 250, 25 parts is simply going to be 5 multiplied by 250, right? So this is going to give me 250 by 5, that's 1250 milliliters, right? So that's the total, that's the container of juice. So you have a container, that's how much it's filled with, right? And they want to answer in liters. If you want to convert this to liters, we divide by 1,000. So this is 1.25 liters, right? So that's the total volume of juice in the carton. And the second part, calculate the volume of orange juice in the carton. So in this case here, what's the ratio for orange is the first one, right? Orange is the first one, so that's 9 parts, right? So we already know that 25 parts, right, as a full amount of juice here, that is equal to 1.25 liters, right? So if I want to work out for the juice, which is 9 parts, right? And for those of you not sure what we're going to do here, we're going to take this number, think of it as cross multiplying. This number multiplied by 1.25 divided by this. So that's 9 by 1.25 all over 25. And you're going to get right, 0.45 liters, right? Or if they wanted it in milliliters, because they didn't specify here, right, it's going to be 450 milliliters, right? So these are the kinds of questions that could potentially come in question 1. So remember, this is a sample paper, one of my sample papers here, right? It's not, it's just one of my sample papers, right? Question 2, like I said, is usually based on algebra. So this is question 2. So the first one here, we want to simplify. So if you want to simplify this here, we're going to use our indices rules, right? So in this case here, it's going to be 2 cube, right? So we have to cube the number first, and it's also going to be x cube, right? In which case, you're going to get 2 by 2 by 2. That's 2 2s are 4 2s are 8. So this is going to be 8x to the power 9. All I'm doing here, I'm using an indices rule in order to treat with this, right? So that's part 1. Part 2, we have division, right? And you're going to use an indices rule again here, right? So to do this, since you're dividing, you have to subtract your indices. So it's going to be 7 minus 2, in which case this is going to be y to the power 9, right? So that's the answer for part 2. For part 1 here, B part 1, we want to factorize. So I have 7x squared minus 21x cubed y squared. So just by looking at it, you should be able to recognize that we're going to use the HCF method here, right? There are 4 different factorizing that CSEC can give us. The HCF method, factorizing by grouping, difference of 2 squares, and a quadratic, right? Those are the 4 that it could give you in the exam. So for this one here, we look at the highest number that can go into 7 and 21. That is 7. Then we look at the x squared and the x cubed. The highest variable that can go there is x squared. And that's the only thing we have common. So open brackets. So this is going to be 1 minus, if you want to get back the 21, this has to be a 3. We need to get x cubed, so you need to put an x here. And we need to get y squared, right? So that's the answer for part 1. For part 2, right, when we look at that, we can see 25p squared minus q squared. That's the difference of 2 squares. So in this case, the answer should be 5p plus q in one bracket, right? 5p minus q in the second bracket, right? That's it. Now the third one here, right? It is 4 terms. And usually when we see a question that has 4 terms in it and you want to factorize, there's a good chance that it's it's factorizing by grouping. So let's factorize this by grouping here. 6ap plus 4bp minus 3aq minus 2bq, right? What we're going to do here, we're going to group our terms. So I'm going to factorize the first 2. So you can pull out 2 here, and you can pull out p here, open brackets. This should be 3a, 3 2 is 6, yeah, plus 2, because you want to get back 4, and this has to be a b, right? So that's our first, all I've done is factorize these first 2 terms here. The next one here now, right, we put a minus sign here, and the only thing we can pull out on this side here is q, in which case this is going to be 3a plus 2b, right? Now here's a little thing that you should pay attention to. Whenever we have a factorizing by grouping question, if for some reason you factorize and these 2 brackets are different, then something is wrong with your answer, right? So those 2 brackets must be the same when it comes to factorizing by grouping. So for this one here, the final answer now is simply going to be, you write down what the common bracket was, 3a plus 2b. And the other bracket now will be 2p minus q, right? That's your answer for B part 3. Right, just kind of skimming the chat here. I'm going to repeat this again. This is not the paper that is coming tomorrow, right? I will never leak a maths exam, right? I will never leak a maths exam, right? This is just one of my sample papers, right? So part C, the diagram shows a square and a rectangle, and the units are in centimeters. The area of the square is 1 cm greater than the area of the rectangle. So let's go back here. So we have a square and we have a rectangle, right? And they gave us the dimensions of the square as x plus 2, that's one side. In the rectangle, we have 3x minus 1 and we have x, right? Now, if we read the question here, the question says that the difference or the area of the square is 1 cm greater than the area of the rectangle, right? So let's think about this for a sec. So the area of square, right, is equal to 1 centimeter greater than the area of the rectangle. So therefore, if I take the area of the square and I minus 1, that should be equal to the area of the rectangle, right? Right? Now let's read this again, because sometimes some students, they have trouble understanding certain things. So the diagram shows a square and a rectangle, not drawn to scale, and the units are in centimeters. The area of the square is 1 cm greater than the area of the rectangle, right? So that means that if I take the area of the square and I subtract 1, I should get that equal to the area of the rectangle, right? That's what it means. So what we're going to do, we're going to plug the information, because part 1 says to show this, right? So the area of the square is going to be x plus 2, right, squared, right, minus 1, right, is equal to the area of the rectangle, which is going to be x by 3x minus 1, right? Now, x minus 2 squared actually means, and this is something that students make a mistake with in the exam, x plus 2 squared means x plus 2 multiplied by x plus 2. That's what it means. When I expand this, I'm going to get x squared plus 4x plus 4 minus 1. If I remove the brackets on the right hand side, I'm going to get 3x squared, right, minus x, right? Now my answer doesn't look like what we have here as yet. So let's carry everything to the left side. So you're going to get x squared minus 3x squared plus 4x, right, plus x plus 4 minus 1 is equal to 0, right? Now when I simplify this, I'm going to get minus 2x squared. 4x plus x is going to give me 5x. And then 4 minus 1 is going to give me plus 3. is equal to 0, right? Now my answer kind of starting to look like it, but in their answer we have 2x squared, so let's multiply everything by -1. So you're going to get 2x squared minus 5x minus 3 is equal to 0, right? So therefore I have proven what they asked me to prove, right? So we can be given a worded problem and come up with an equation, right? All right, so that is part 1, right? Part 2, we want to solve this equation. Well, you have a quadratic here and you want to solve a quadratic, right? So the easiest thing to do is to attempt to factorize the quadratic, right? So let's put a 2x here, let's put an x here, let's put a 1 here, 3 here, right? Plus minus, does that make sense? 2x by x is 2x squared, 1 by -3 is -3, 3 to the 6. Okay, so this looks correct here, right? So what I've done here, I've factorized the quadratic, and to solve the quadratic now, you're going to put 2x plus 1 is equal to 0, 2x is equal to -1, and therefore x is equal to -1/2, right? So that is one value for x. The second value will be x minus 3 is equal to 0, and therefore x is equal to 3. Now, if this were a real CXC question here, right, and they were to ask us what is the length of, let's say, the square, right, the length of one side of the square, you have to be careful how you choose your answers. Because you notice when I solved the quadratic, I got +3 and I got -1/2. You cannot get a negative length. So you need to interpret what equation or what it's telling you, right? So that takes care of question 2. This one here is question 3. So we know question 3 is on geometry and transformations. So we have 2 pairs of parallel lines, right? So this line here is parallel to this line is parallel to this line, right? And we want to figure out the angles A, B, and C, right? So let's see. So angle A, right? Angle A is simply going to be 32 degrees. And how do I know that? This 32 up here is alternate with this angle here, right? So you all need to know your reasons for why certain angles are the way they are. So this here, these are alternate angles. That's why I know that. There's no calculation there. So alternate angles, right? So that's A. In the case of B, can work out B, right? What can we do there? Let's see. So this is 50 here, right? This angle here is 50 here, right? Now because this line here and this line here are parallel, I can say that this angle here is 50 degrees. I can say that, right? So therefore I have a triangle. So therefore B is simply going to be 180 minus, let's add up the 50 plus the 32, right? So that's going to give me 98 degrees, right? So this angle here is 98 degrees, right? And the last angle that we want to figure out here, we want to figure out what is, we want to figure out what is C, right? So again, we can use the fact that this whole angle here, right, is alternate with this whole angle here. So therefore C is simply going to be 32 plus 50, right? And that's going to give me 82. Right? So we can get a simple question like this based on some simple geometry rules, right? What you should also learn as well, guys, you all need to know your formula to find the total or the sum of the angles in any polygon, right? Make sure you learn that formula. Sum of the angles in a polygon, you all need to know that formula. Right, so typically we get a question on transformations, and what CXC has been doing, they have been bringing all 4 transformations in one question, right? So we have some diagrams here. We have A, B, C, and D. All of these are triangles, right? And the first thing we want to do in part A, part 1, we want to describe fully a single transformation that maps A onto B, right? A onto B. Right? We want a single transformation that maps A onto B. Any ideas? Right? Now, whenever you have a transformation, to figure out what is the transformation, right? So if you look at a triangle A and triangle B, right? This is triangle A here, this is triangle B here, right? Now, if you look at the two triangles here, you realize that the two triangles, they are identical, right? So those triangles are said to be congruent, right? Whenever you guys see something like that, it means that the two triangles are congruent, right? Now, the next thing is that you will notice that the orientation has changed, right? The orientation has changed. So because the orientation has changed, right, we can tell that this is clearly a rotation, right? That's what this is. It's a rotation, right? Now, one of the things that you're going to have to be able to do in the exam, right, is to be able to see what kind of rotation it is, right? So it's not just a matter of saying rotation, right? So we need to say rotation, yes. Right? We need to specify whether it's clockwise or anti-clockwise. If you look at what's happening here, it appears that this thing is rotating this way. So therefore that's anti-clockwise. So it's a rotation anti-clockwise. Right? We must also specify the angle. Right? Now if, let's say we use this as our center of rotation here. Right? And I were to draw a line from here to here. And I were to draw a line from here to here, right? What is happening here is that we are rotating by an angle of 90 degrees. So we must specify 90 degrees, right? About, we need to specify the center of rotation, right? So that's a coordinate we need to give them. In this case here, I'm rotating this triangle about this point here, the origin, right? So that's what we're looking at there. That's the answer for that part. So whenever you are asked to describe a transformation, and if it's a rotation, you must say it's a rotation. You must say whether it's clockwise or anti-clockwise. You must also give the angle, and you must also give the center of rotation. You need to say all of those things in order to get full marks for that. If you put rotation alone, you're going to get 1 mark only, right? Right? Some people saying 270 degrees rotation clockwise. Sure, you can say that as well, right? If you want to say clockwise, you can say clockwise, but specify the angle as 270. Yeah, you can do that as well, right? Right? I'm doing a whole sample paper here, so this it'll take a little while to finish the the session, right? Yeah, clockwise is fine. You all can say clockwise, just specify 270 degrees, right? Some people are asking how to find the center. So there's a complicated way to find the center, right? Using construction, right? Or what we could do is use your compass. In the exam, you can use your compass, right? Now, I don't have enough time to show you all of that, right? In one of the earlier videos, you should have seen a sample pertaining to that, right? Now we want to map triangle A onto C. So this here is triangle A, and this is where C is, right? When you look at the diagram, you realize, wait a minute, A and C are identical, right? So the geometric word for this is congruent. If in the exam they ask you to describe the relationship between the two triangles, they are said to be congruent, right? Now, if you notice, what's happening here is that this triangle is really just shifting this way. So that's a translation, right? To figure out the translation vector, because that's what we normally need to figure out, you're going to first start by figuring out, let's say we start with this point here, right? You just select one of the points. And we go 1, 2, 3, 4, 5, 6. So we went 6 units to the left. So the vector is going to be -6. And then we go 1, 2, 3 downwards. So that's -3, right? So these two numbers tells us about the direction in which we're going to move. So the answer is going to be translation. That's what you need to see, right? It's translation using vector -6, -3, right? So once you're describing a translation, you must indicate what the vector is. The third part, triangle A onto D now. So when you look at triangle A, this is triangle A here, and this is triangle D here. So the first thing you're going to notice is that, wait a minute, triangle A and D, the correct terminology to describe them, they are similar triangles, right? They are similar triangles. They are not congruent, but they are similar. What you will notice is that triangle A has gotten bigger. So we know it's going to be an enlargement. That's what it is. So you're going to say enlargement, right? But there are two things needed for the enlargement. We need to know what is the center of enlargement and what is the scale factor. So enlargement, and if you all want to figure out where is the center of enlargement, this is what you need to do. With your ruler, right, you're going to draw some construction lines. So you can do this. Join, let's say this part here to this, right? Now draw more than one line, please. I'm going to join, let's say, this point of this triangle to here. Right? And let me draw next one here. Right? So if I were you, I would draw 3 lines to make sure that all of them passing through the same point. Right? Right? This one looking a little off here. Right. So you will notice that all of these projection lines here, all of them pass through this point here. The coordinates of that point there is going to be 6, 4, and that's important to us. Right? So you're going to say enlargement of scale factor. Right? I need to work out the scale factor still. Right? Scale factor, and we need to work that out. K equal with center of enlargement. Right, so the center of enlargement here, we work that out by drawing the construction lines. That's 6, 4. So you're going to say 6, 4 here. Right? To work out the scale factor, all we need to do, we need to compare 2 lengths. So let's say we look at the height of the triangle here. This is 1 unit. But when you look here now, you realize this is 3 units. Right? So this length has increased by a factor of 3. So therefore, the scale factor, right, K is equal to 3. That's it. Right? And part B now, on the grid, draw the image of A after reflection in the line y is equal to -1. So we're doing a reflection, right? And we're looking for the line y is equal to -1. Now, y is equal to -1, right, is a horizontal line. That's something you need to know, right? So what we're going to do, insert... Right? So we're going to draw y is equal to -1. Y is equal to -1 is this line down here. Right? So this is the line y is equal to -1. That's what I've drawn. Right? That's your mirror line. That's what you're going to do this reflection in. Right? So we take in this triangle A here, right? This triangle on top here, and you're going to reflect it in that line. Now, if we look at how far it is in front of the mirror line, from here to here, that's 2 units. So therefore, this here is going to be part of the triangle, right? So you don't need to do anything fancy here, but all we need to do is a complete triangle like this, right? So this is going to be, this here is the image after you reflect it in a line y is equal to -1. That's it. Right? I hope you all doing okay there, right? Don't get too scared, right? Don't get too scared, right? All right, so that's my third question here, right? That's my third question. So question 4, I told you all in class, question 4, you're going to get functions in question 4, right? So we have a function here, f of x is 2 minus 3x, and the first thing we want to work out is f of minus a 2. So this is easy, right? So f of x is equal to 2 minus 3x, right? And if you want to get f of negative 1/3, right, this is going to be 2 minus 3 by negative 1/3, right? So we just substitute it. That's all we're doing. This is going to be 3 by minus 1/3 is going to give us plus 1. So therefore, this answer here is going to be 3, right? So that's the answer for part 1. Part 2, we want to work out g inverse of 3, right? Now, all we need to do, we need to first find the inverse of this function here, right? And there are a few steps we need to follow. So step 1, we're going to let y equal to 2x plus 9. Then the next step is to interchange x and y. So anywhere we see x, we put y. Anywhere we see y, we put x. So x is equal to 2y plus 9. So therefore, 2y plus 9 is equal to x. So we're making y the subject of the formula. So 2y is equal to x minus 9. And therefore, y is equal to x minus 9 all over 2. So therefore, what I just worked out here was the inverse of that function. So g inverse is equal to x minus 9 all over 2, right? So the question asks us for g inverse of 3. So what we're going to do, we're going to plug this 3 into that formula there. So this is going to be 3 minus 9 all over 2. So 3 minus 9 is going to give you minus 6 over 2, and you're going to get minus 3, right? Hope that's correct. Minus 6 plus 9. Yeah, that looking correct there, right? So that's simple function question, right? Now, you could be given a full question on functions. So the whole of question 4 could just be a function question. Or they could kind of have part that involves some kind of coordinate geometry inside it, right? Equation of a line, something like that. So we have a graph here showing the line P. And the first thing we want to do is to determine the equation of P, right, in the form y is equal to mx plus c. So let's go across here. So you are being asked to work out the equation of a straight line. All straight lines have an equation given by y is equal to mx plus c, right? Now, we need to know what is the gradient. That's a constant. We need to know what is the y-intercept. If you look at the graph, you already know what the y-intercept is. So we know that c is actually equal to minus 3. You already know that based on the graph. So all I need to do is to work out the gradient m. So m is given by the formula y2 minus y1 all over x2 minus x1. You all need to know that formula. It is not given to you in the exam. So what you need to do, you need 2 points on that line in order to work out the gradient. So for me, I will use this point, which is 0 minus 3. And I will use maybe this point here, which is 6, 0, right? Now, this is what I normally tell my class to do, my actual class. Label these points. So call this x1, call this y1, call this x2, call this y2, right? Once you label there, it's just a matter of substituting into your formula, right? So in this case here, y2 is 0. So it's going to be 0 minus 3 all over 6 minus 0. So 0 minus 3 is going to be positive 3 divided by 6. So therefore, this is a half, right? So therefore, that is what m is. So therefore, the equation of the line right, is given by y is equal to a half x minus 3, right? So this is the answer here. Y is equal to a half x minus 3, right? Right. So alright guys, so just remember to hit like and subscribe, right? Please remember to hit like and subscribe, right? Let's see. So that is part 1, right? So now the second part here says the equation of the line Q is given by x plus y is equal to 3. And we want to state the coordinates of the x-intercept, right? So we have an equation of a second line here. X plus y is equal to 3. And we want to know what is the x-intercept, right? Now, one of the things that you all need to remember when it comes to straight lines, so this is your x-axis. That is also called the line y is equal to 0. This is your y-axis, and that's called the line x is equal to 0, right? So we have x plus y is equal to 3. So if you want to get the x-intercept, that is where you're cutting the x-axis, you need to put y is equal to 0 into this equation, right? So this is part 2. So we're going to say when y equals 0, right? You're going to get x plus 0 is equal to 3. So therefore x is equal to 3, right? So this x-intercept here is going to be 3, 0, right? That's where the graph is going to cut your x-axis at 3, 0. So somewhere here, that's going to be 3, 0. Right? The third part, state the coordinates of the y-intercept, right? So the coordinates of the y-intercept is where do I cut the y-axis? When you cut the y-axis, x is equal to 0, right? So again, this is the third part. You're going to say when x is equal to 0, right? You're going to get 0 plus y is equal to 3. So therefore, y is equal to 3. So therefore, that coordinate of the y-intercept here is going to be 0, positive 3, right? So this here is 0, positive 3. So this line that we're talking about here looks like this. That's the line that we're talking about. That's the line Q, right? Now, the next part here, part 4, says draw the line Q on the same graph, right? So we can draw that because we know two coordinates on that graph, 3, 0 and 0, 3. So let's go here. Right? So 3, 0 is this line here, this point, sorry, and 0, 3 is going to be here. Now we want to draw the line Q. So again, we're just going to take our ruler and we're going to draw a line passing through these 2 points. Right? So this is line Q here that we're talking about. This is line Q, right? The next part of the question says the lines P and Q represents a pair of simultaneous equations. Using the graph, state the solution to the pair of simultaneous equations. So if we have two lines P and we have Q, right, and you want to solve them as a pair of simultaneous equations, then all you need to do is to figure out where do these two graphs intersect. So if you notice something here, both of them, they're cutting at this point here, which is 4 minus 1, right? So this is 4 minus 1. So therefore, the answer, all you need to tell them here is that x is equal to 4, y is equal to minus 1. That's it. That's all we need to do, right? So that takes care of question 4, right? Question 5. So question 5, as you guys know, is going to be based on statistics, and any number of things can come here. You can get a line graph, you can get a histogram, you can get a cumulative frequency curve, a frequency polygon, any one of them, right? I cannot do every single question on them, right? So we can also get pie chart, which is what this question is going to be based on. So a group of 600 people were asked to select their favorite type of movie. The pie chart illustrates the data collected. Show that 175 persons like action movies, right? So let's see. We have 600 people, right? And this here represents our action movie, right? And that represents 105 degrees, right? Now, the full circle is equivalent to 600 people. So what you could do, you can say, all right, so 360 degrees, that's a full circle. That corresponds to 600 people, right? But if I want to work out for 105 degrees, right, what you're going to do, you're going to cross multiply. Take this number, multiply by 600, divide by 360. So this will be 105 multiplied by 600 divided by 360. When I work this out, I'm going to get you're going to get 175. 175, which is what they told us to prove here, right? So 175 persons like action movies. Yeah, that's the answer. The next part 2, calculate the number of persons who like drama, right? So again, we're going to do the exact same thing we just did here. But this time drama is 60 degrees, right? So we're going to put, I'm trying to get space to work this out here. So we're going to say, again, 360, right? That is equal to 600. And you want to work out for 60 degrees. So 60 degrees, right? That's going to be, you're cross multiplying. So 60 by 600 all over 360. Right? And I'm getting 100 persons, right? I'm getting 100 persons, right? So that's the answer. So this one here is 100 persons. And the third part, 120 persons like comedy, right? And the remaining like romance, right? So we have two more types of movies here, comedy and romance. Calculate the angle of the sector that represents romance, right? Now, this is the remaining here. This is the remaining section here, right? And within the section here, we have 120 persons liking comedy, right? So let's see. Let's work out the angle for comedy, right? Let's work out the angle for comedy, right? So this looks simple, but it's not that simple, right? So for comedy, we have 120 persons. So to figure out the angle, right, we can say 120 over 600, right, multiplied by 360. That's going to give us the angle for comedy, right? So that's 120 divided by 600 multiplied by 360. You're going to get an angle of 72 degrees, right? So therefore, this is comedy here, right? And this angle here is 72 degrees, right? Now what that does, it allows me to figure out, so the remaining here now is romance, right? So we need to figure out what is this angle for romance here, right? So to get that angle, all we need to do is to take 360, right, minus, we need to add up 105 plus 60 plus 27, right, plus 72, right? I don't have enough space here, but I hope you get the gist of what I'm doing. So that's going to be 360 minus 105 plus 60 plus 27 plus 72, right? And you're going to get 96 degrees, right? So therefore, this romance angle here is 96 degrees, right? And the question asks us, what is the angle of that sector? So the angle is going to be 96 degrees, right? So to be honest, I do feel that we might be getting a question on a pie chart tomorrow, possibly, right? That's my feel. All right, I'm just kind of skimming through the chat here. Right, there are too many messages here for me to check anything, right? All right, so let's move on, right? So that's question 5 here, but we're not finished as yet, right? Part B is based on a cumulative frequency diagram, and it shows a mass of a group of 100 boys, right? So we have cumulative frequency and we have mass in kilograms, right? The first thing that we want, estimate, we want the median, right? So whenever you want to find median from a cumulative frequency curve, we look at the largest number here, which is 100. So therefore, we're going to go to the graph and you're going to read off at 50. Now, the most common mistake that students make here is to assume that the answer is 50. The answer is not 50, right? Let me just make this a little thicker. Right, so this is one. I need another one here. Right, so what we're gonna do, so you have 100 boys, so we're gonna read off at 50, right? When you read off at 50 here, according to my graph, I'm getting around 62 kilograms as my median, right? Now remember, it's an estimate here, so this is about 62 kg, right? Next thing we want here, we want to get the upper quartile. So upper quartile, right? So your upper quartile, right, is what we call our Q3. That's not. What did I do here? Yeah. Right? So what I just worked out there was the median. The median is called Q2. The upper quartile is what we call our Q3 value. Right? So the upper quartile, you need to find 3/4 of this 100 here. Right? So to find the upper quartile, you need to read off at 3/4. Now 3/4 of 100 is 75. So what we need to do, we need to come across here. And what we're going to do, we're going to read off at 75. That's what you do. Right? So you're going to take your ruler in the exam and you're going to draw a line at 75. And then we're going to come across here and you're going to, remember it's an estimate, right? So some answers may vary for some students, right? So this estimate here looks like about maybe 69, right? So your Q3 or your upper quartile is about 69 kilograms, right? So this here is going to be 69 kg, right? And then third part, we want to get the semi-interquartile range, right? Now to get the semi-interquartile range, right? Semi-interquartile range is actually a half of Q3 minus Q1, right? That's the formula we're using to work out the semi-interquartile range, right? Now I already worked out Q3 and I got 69, right, kg, right? The Q1 was the Q2 was 62 kg, right? Your Q1, which is your lower quartile, you're looking for a quarter of 100, which is 25. So again, you're going to go to the graph and you're going to draw a line at 25. Right, so again, I'm reading off this value here, and that looks like about 54 kg, right? So this Q1 here looks like 54 kg, right? So that's how you're going to read off these things here. So you need to remember how to determine upper quartile, how to determine median, and how to determine your lower quartile. So all I'm going to do is to plug it into the formula. So it's going to be a half by Q3, which is 69, minus Q1, which is 54. So this is going to give us 7.5, right? So my semi-interquartile range here is 7.5 kilograms, right? Right, so again guys, I'm going to repeat it again. This is not the paper that is coming tomorrow, right? The next part here, part 4, right? The number of children having a mass greater than 75. So the number of children having a mass greater than 75. So what you're going to do, you're going to look to see where the mass of 75 is, right? So this is going to be here. Right? And we need to read off that cumulative frequency there. So that cumulative frequency there is actually 90. But what you need to remember is that when it comes to a cumulative frequency curve, it always gives us less than values. Right? If you all have never seen this before, a cumulative frequency curve gives us less than information. So the question says, right, the number of children having a mass greater than 75. So from the graph, right, when I read off 75 here, this is 75, that corresponds to 90 people, right? But 90 is not the answer. What you need to do here, you need to take the total number of people and subtract the 90, and you're going to get 10. So the answer is going to be 10. The number of children having a mass greater than 75 is going to be 10. It's not 90. And then the last part of the question, the probability of a boy selected at random has a mass less than 55. So again, you go to the graph, right? You need to locate where is 55. So for me, 55 is going to be here. Right? Now this is an estimate here, so answers could vary slightly. It's looking like about 29 for me here. Right? So that corresponds to a cumulative frequency of 29. So therefore, the probability is simply going to be, because they said less than, is going to be 29 over the total number of children that we have, which is 100. So the probability of selecting a boy having a mass less than 55 is going to be 29 over 100. Right? So that takes care of question, which one is this? Question 5. Moving on, question 6 in your exam is going to be based on measurement, right? Question 6 is going to be based on measurement, right? Right, so the diagram, not drawn to scale, it shows a prism. So we have a prism here, right? A, B, C, D, E, F. AB is 5 cm, AC is 13, and CF is 20, and angle ABC is 90. So the first thing we want to calculate the length of BC. So this here is a right angle triangle, right? And we want to get this length here, BC, right? So if it's a right angle triangle, I can use Pythagoras' theorem to work out BC. So in my online classes, I tell my students, don't just learn off the formula, because you need to know how to use the formula. So what I will do, I'll write it in terms of Pythagoras' theorem. So BC squared plus 5 squared should be equal to 13 squared. All I'm doing is applying Pythagoras' theorem. So therefore, BC squared is equal to 13 squared minus 5 squared. So that's going to give me, that's 169 minus 25. You're going to get 144. So therefore, BC is the square root of 144. So therefore BC is equal to 12. Right? So that's the answer for the first part here. This is 12 cm. This is 12. Right? Part 2 now, we want to calculate the volume of the prism. Right? Now, whenever you have a prism, right, the volume, so this part 2, the volume is equal to the base area or the cross-sectional area, right, multiplied by the length of the prism. Now, this is a triangle, right? This cross-sectional area is a triangle. So the area of that triangle, so it's A by L. That's how we work out the area of a prism. So the area of the triangle is going to be a half by base by height. So half by 12 by 5, right? And you're multiplying that by the length of the prism, which is going to be 20. So the total volume of the prism here is going to be T by 20, 600 cm cube. Right? So that's the total volume of the prism. That's the answer for this part. Right? Now the third part, we want to calculate the total surface area of this prism. Now lots of students have difficulty working out total surface area. Right? But my advice to you, when you have a question like this, you need to figure out how many faces do I need to account for. Right? The total surface area will be the area of this triangle here, which we worked out already, right? That's 12 5s are 60 over 2. That's 30 cm squared. So that's the area of that face. This face is identical to that. So this area is also going to be 30 cm squared, right? Now there are 3 more faces we need to account for, right? I'll use a different color so you could see. So the base, right? This base here, right, is going to be 12 by 20. That's a rectangle. So this here is going to be 12 by 20. So that's 12 2s are 24. So that's 240 cm squared. Right? That's the area of the base. Now when it comes to the back of the prism now, so this piece here in the back, right? That's a rectangle as well. You can work out that area. That's going to be 5 by 20. Right? That's going to be 100 cm squared. Right? So that's the back you worked out there now. There's one more piece that we need to account for, which is the slanted piece. Right? So the slanted piece here is, I don't know how to draw this for you all, but this is the slanted piece here. Right? And that slanted piece there will have an area of 13 by 20. Right? Which works out to be 260 cm squared, right? So whenever you have a question where you have to work out the total surface area, we need to account for all the area, right? So in this case here, your total surface area will be the 2 triangles, so that's 30 plus 30, right? The base, which was 240, right? Plus the back piece, which was 100, plus the slanted piece, which was 260, right? So when it comes to a question like this, you have to make sure you account for all the faces. When I add this up here, I'm going to get 60. Right? I'm getting 660. Right? So let's see what's happening here now. Right, so that's the total surface area. The next thing here, right? We have 1.2 liters of water, right? So you're pouring some water inside here, right? is poured into a cylinder of radius 7 cm. Calculate the height of the water in the cylinder, right? So first things first, we need to convert this 1.2 liters into cm cube. So 1.2 liters, if you want to convert that to cm cube, you need to multiply by 1,000. So this is going to be 1,200 cm cube, right? So that's the volume of the liquid or the water that you're pouring into this thing here. So it's 1,200 cm cube, right? Now, they told you the radius of this thing here, right? So this is the radius here, and the radius is 7, right? That's the radius of this thing, 7 cm. So all we need to do, the volume of our cylinder is given by pi r squared h, right? Pi r squared h, and that's equal to your volume. So we're going to assume, so sometimes it may tell you to take pi as 22/7, or you may be asked to take it as 3.14. Let's say 22/7. So pi, which is 22/7, right, multiplied by the radius squared, which is 7 squared, multiplied by h, which I don't know, is equal to your volume, which is 1,200. So h is equal to 1,200 divided by 22/7 multiplied by 7 squared, right? So therefore the height of the liquid or the height of the water is going to be right, and I'm getting about 7.8 cm, right? So you can approximate here, right? You can approximate here. Right, so this is part B here, right? So that takes care of question 6. Question 7. So question 7 in your exam is always going to be based on some sequence or some pattern or something like that, right? So the grid shows 3 figures in a sequence. So we have 3 figures here, figure 1, figure 2, figure 3, and we want to draw figure 4, right? Now, what you need to do when you're drawing these figures here, right? Look to see what is actually changing when you jump from one figure to the next. That's what you're doing, right? So in this case here, the only change that took place is that you added 3 more squares, right? When you jump from figure 2 to figure 3, right? What we did here, we added some more in order for us to create another square, right? So if I want to create figure 4, it should have a height of 4. Right, in the real exam, if you have to draw a diagram like this, make sure you use a ruler, right? Unless you're running out of time, but 1, 2, 3, 4, 1, 2. Right, so this here is, now I need to put these dots, right? Because it's made up of dots and right? So this here is your figure 4, right? Now usually when they give us a diagram, they may ask us to complete a table like this, right? So the table shows number of dots D, right? It has the area and it has the number of lines in the first 3 figures, right? So number of dots. So what I normally do in a question like this, I will go to my diagrams and make sure I understand how they got this here. So if we look at the first one here, figure 1 has 4 dots, area is 1, and number of lines is 4. So if you look at this first figure 1 here, we have 4 dots, we have 4 lines, and the area is 1, right? So that makes sense. When you look at figure 2, we should have gotten an area of 4, right? And we should get number of dots being 9. So let's see if that's happening in the table. So if we look here, figure 2, right? Number of dots is 9, the area is 4, and the number of lines is 12. So this makes sense, right? I understand what's happening here. Now, in the fourth figure, right, and what some students don't realize is that sometimes when you draw the fourth figure, you get the information from the diagram itself. So if I go to the fourth figure, number of dots, right, the number of dots here, if I were to check this, right, 1, 2, 3, 4, 5. So you have five rows here. So 5 by 5, you have 25 dots in total. So you can count it or you can calculate it. But on this diagram here, I have 25 dots, right, in terms of the area, right? So that's now. So dots is 25, right? The area, in this case here, is going to be 1, 2, 3, 4, is going to be 16, right? And the number of lines, right, is going to be, let's see how we're doing this. 1, 2, 3, 4. 4 for the 16. I'm seeing 36, right? So you can check it and see what you get it, right? So number of dots is 25. That's what I'm getting. So number of dots is 25. This one here is 16. And the number of lines I'm getting is 36. So I got that straight from my diagram, right? Now, you want to complete the table. So this is what I would normally tell my class to do, right? Don't guess. What you should do is to go and work out the last row one time. Try to figure out what is the formula, right? Now, usually there's a relationship between the figure number and whatever we're working with. So you will notice that figure 1, right, you have number of dots being 4. But if you look at all these numbers here, all of these numbers here are square numbers, right? So in terms of figure 1, right, if I want to square this, it is going to be n plus 1 squared, right? That's what the formula is going to be for the number of dots. You're adding 1 to the figure number and you're squaring it. So if I add 1 to 2, I'm going to get 3. 3 squared will give me 9. If I have figure 4 and I add 1 to that and I square it, I'm going to get 16. So that's the formula for the number of dots. Now in terms of area, right, if you watch the area here, all they're doing, they're just squaring the figure number, right? So this one here is simply going to be n squared. That's all they're doing, right? And for the number of lines now, you will notice that when I jump from here to here, I've added 8, right? When I jump from here to here, you've added 12. And when you jump from here to here, what you've added again? You added 12 again. That's all. Let me see something. Something looking a little off here. First figure, we have 1, 2, 3, 4 lines. Then we have 1, 2, 3, 4, 5. 4 lines, then 12. 1, 2, 3. 4 trees are 12. One second, let me check something here. 1, 2, 3, 4, 5, 6, 7. $24, 36. Right, so all right, so we have that there, right? So we started off with a difference of 8, then 12, then 12, right? So what I will do, so let's work out, I'll work out this row here. This row seems to be an easy one. So in this case here, right, when you have 121, right, that means that n squared is 121. So therefore, I can work out what figure number that is. That's the square root of 121, and that's going to be 11, right? So this corresponds to figure 11. If I want to get the number of dots, it is going to be 11 plus 1 squared. So that's going to be 11 plus 1 squared. So that's going to be 12 squared, and that's going to be 144, right? So the number of dots here is 144, right? Let's work out this row here, right? I'll come back to the number of lines in a sec, right? So we know that the number of dots is 49. So what you can do, you can put n plus 1 squared is equal to 49. So n plus 1 is the square root of 49. So therefore n plus 1 is equal to 7. So therefore n is equal to 7 minus 1. So therefore n is equal to 6, right? So therefore this corresponds to figure 6. And if I want to get in the area is going to be 6 squared, which is 36, right? Now let me go back to the number of lines. I'm trying to think if I had graded this out in the original question, right? Let's check something here. Number of lines in the first one. So we had 4 lines in the first one, right? Then when we jump to the second one, I have 12 in the table. Is 12 correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, 12 is correct, right? And then when I jump to the third one, right, that will go to 24, right? So hopping in here. Let's leave this one out here for now because I can't remember if I'd grayed out this in the original question, right? Let's leave this out for now here, right? Because what I notice in here is that we have an increase of 8, then you have an increase of 12, and then 12, right? N squared. So I'm gonna think about this for a sec, right? Yeah, let's leave that one out for now, right? Let's do the second part instead, right? I need to double check that there. Okay, so this part C of the same question, right? So the total number of lines, right, in the first n figures is given by this formula here. So they give us the total number of lines, right? Show that when n is equal to 1, a plus b is 10 over 3. So n is equal to 1, right? And we want to show that a plus b is equal to 10 over 3. So 2/3 by n cubed, which is 1 cubed, plus a by 1 squared, plus b by 1, right? Show that. All right, let's see what we're gonna get here. 2/3 plus a plus b, right? Right, now when n is equal to 1, that's figure 1, right? If you go back to the diagram, right, the total number of lines in figure 1 here is 4, right? The total number of lines is 4. So this here has to be equal to 4, right? So this is going to be, so let's multiply everything by 3. So you're going to get 2 plus 3a plus 3b is equal to 12, right? So therefore 3a plus 3b is equal to 12 minus 2, which is 10. And you want to prove this is what they have here. So if I divide everything by 3, I'm going to get a plus b is equal to 10 over 3, right? So that's what I did. I proved what they wanted here, right? For the second one here, show that when n is equal to 2, right? So we're going to plug 2 now. So n is equal to 2, and you're going to plug that into this equation here. So this is going to be 2/3 by 2 cubed plus a by 2 squared plus b by 2, right? And that is equal to the number of lines, right? The total number of lines in the first n figures, right? So in this case here, right, the total number of lines in the first n figures here would have been this here. You need to add up the 12 and the 4, right? So that's going to be what, 16? Now hopefully this is correct here, right? 2 cubed is 8. So this is 2 cubed 8, 16. So this is 16 over 3 plus 4a plus 2b, right, is equal to 16, right? Multiply everything by 3. So this is 16 plus 12a plus 6b is equal to 48, right? 12a plus 6b (32), right? And then let's divide everything by 3. So therefore this becomes 4a plus 2b is equal to 32 over 3, right? Which is what they told us to prove here, right? Which is what they told us to prove here, right? All right. So this is what we have here, right? This is what we have here, right? And the last part of the question here is to determine the value of a and b, right? Determine the value of a and b. So what you have here, you have two equations, simultaneous equations. So all you're going to do, you're going to solve the pair of simultaneous equations, right? Let me get a blank sheet here. Right, I see people still talking about leak paper. I am saying this for the millionth time. This is a sample paper, right? This is not a leak paper at all, right? All right, so we have a plus b is 10 over 3. Right, and then we have, what's the next thing here? 4a plus 2b is 32 over 3. Right? So we have two ways we can do this. We can either substitute or we can use elimination if we want. So for me, let's call this equation 1, right? And call this equation 2, right? What I can do, I can take the first equation, right? Let's say I want to eliminate a, right? I can take the first equation and multiply by 4. So you will end up with 4a plus 4b is equal to 40 over 3. Right? Let's write back the second equation, which is 4a plus 2b is 32 over 3. Right? Now, if you want to solve this here, let's subtract these two equations to eliminate a. So you'll end up with 2b is equal to 40 over 3 minus 32 over 3. And you're going to get 8 over 3. Right? So therefore b is simply going to be 8 over 3, right, multiplied by a half. So therefore b is equal to 4 over 3, right? So that's what b is. And if you want to work out a, you can plug it into any one of the equations. So if I plug it in the first equation, a is simply going to be 10 over 3, minus 4 over 3. So therefore A is going to be 10 minus 4 is 6 over 3. So therefore A is equal to 2, right? So simultaneous equation, you have multiple ways you can work that out, right? So that takes care of question 7, right? Moving on to question 8. So this is question 8 here. We have a function here, which is a quadratic, right? And we want to complete this table here. So let me just... Alright, so this is our quadratic function here. And we want to complete the table. So that means that we have to plug in minus 1 into that formula. So f of x is 3 plus 4x, right, minus x squared, right? We working out f of minus 1. So this is going to be 3 plus 4 by minus 1, right, minus 1 squared, right? So this is going to be 3 minus 4 minus 1, right? So 3 minus 4 is minus 1, minus 1 minus 1 is minus 2. So this first value here is going to be minus 2. Then we're going to plug 2 into that formula there. So f of 2 is going to be 3 plus 4 by 2 minus 2 squared. So this is going to be 3 plus 4 2s are 8 minus 4. So that's going to be what? 11 minus 4. So this is going to be 7. Right? And the last thing we're going to do, we're going to work out f of 3. So that's going to be 3 plus 4. So this is 3 plus 12 minus 9. We're going to get 6. Right? So these are my values here, right? When I complete the table, right? All right, so next thing we're going to do now, we're going to draw the graph, right? They tell us to draw the graph, right? So we're going from, we're using the table that we have here. So let me just get a copy of this table. Hold on. Right, so I've plotted some points already on the graph, and it's basically to complete, right? So in this case here, right, so minus 1, minus 2, so this is 1 point here, right? They've already plotted here and here, so the next one is 2 7, so 2 7 is up here, 3 6 is going to be here, right? And then all the other points are plotted in, right? So basically we have a quadratic, right? So we're going to try our best to draw a smooth curve through the points. So as you can see, this quadratic here has a maximum point. Right, so this is your quadratic here, right? That's your quadratic. Next part of the question. They said state the equation of the axis of symmetry. So remember, when it comes to axis of symmetry, right, it's that vertical line, right? Axis of symmetry is a vertical line where we can fold the graph paper along that line, and the left-hand side and the right-hand side of the graphs will line up exactly, right? Right, so this here, that's a vertical line, that's your axis of symmetry, and it's passing through this point here. So the axis of symmetry is going to be x is equal to 2, right? So when they ask you here, state the equation of the axis of symmetry, you're going to say x is equal to 2. That's the answer. State the coordinates of the maximum point. Go back to the graph, right? This is your maximum point here, the highest point on your graph, and that corresponds to 2 7. right? So nothing fancy here. We're just going to write down the answer, right? So the maximum point is 2, 7. Next part here, align x plus y is equal to 7. State the coordinates of the x-intercept, right? So we just did a question similar to this. So x plus y is equal to 7. So to get the x-intercept, right? Sorry, the y-intercept, x has to be equal to 0. So you're going to put 0 into this. So you're going to say when x is equal to 0, 0 plus y is equal to 7. So therefore y is equal to 7. So the y-intercept is going to be 0, 7. That's the answer for this part here, right? To get the x-intercept, what we need to do, we need to put y is equal to 0. So we're going to say when y is equal to 0, right? X plus 0 is equal to 7. So therefore x is equal to 7. So therefore this coordinate here will be 7, 0, right? So we know exactly where that graph is cutting the x-axis and the y-axis. Part E says to draw the line on the graph. So you're going to plot 7, 0 and 0, 7. So 7, 0 is going to be here and 0, 7 is going to be here. So what we're going to do, we're going to draw using your ruler, right? You're going to draw a straight line passing through 7, 7 and this point here. Right? So that's the line they're talking about here. This is x plus y is equal to 7, right? Then the next part here, state the solution for this pair of simultaneous equations. Now, I'm not going to do this now here, but we can do this manually if we need to, right? Or we can solve a pair of simultaneous equations graphically, right? If we had to do it manually, you'd make y or x the subject and you would have plugged it into this formula here. But what I'm asking for is for us to solve it graphically. So when you come here now, you're trying to figure out where does the straight line cut the x-axis, sorry, where does the straight line cut the curve, right? So it's cutting at this point here and it's cutting at this point here. The coordinates for this point here is 1, 6. Right? And the coordinates for this one here is 4, 3, right? So those are the 2 points. So when they ask you here in the question, solve or state the solutions. So we're going to say when x is 1, y is equal to 6. That's one solution. And the second solution will be this point here, which is 4, 3. So when x is 4, y is equal to 3. Right? Right? So, I've inserted another question here because I have a feeling that we may get a question on velocity time graph tomorrow, right? I feel so. So we have a bus travels between 2 traffic lights and the speed time graph is shown below. Calculate the acceleration in the first 10 seconds. So that's easy. If you want to get acceleration from a graph like this, all we need to do is to find the slope of that line. So the acceleration is simply going to be, and a quick way of working this out is to take this length and divide it by this length here. So that's going to be, this is 16 and this length here is 10. So this is going to be 16 over 10 and that's going to be 1.6 and its acceleration, so it's meters per second squared, right? So we have to be able to calculate acceleration from a speed time graph. The second part, the average speed for the first 20 seconds. Now, average speed is simply total distance over time, right? Now, this one a little tricky here because what they want up to the first 20 seconds. So what we need to do, we need to find the area of this triangle, find the area of this rectangle, and that will give us the total distance traveled, right? So this is a 2-part process. So this area here is a triangle, so that's a half, multiplied by 10, multiplied by 16, right? So that's going to be what? Half of 16 is 8, 8 by 10 is 80. So this is 80 meters covered in the first 10 seconds. Then we're going to work out for the rectangle. So that's going to be 10 multiplied by 16, so that's going to be 160. So the total distance right, is equal to 80 plus 160, right? And that's going to give us a total of 240 meters, right? So the average speed is simply going to be 240 all over the total time. Now the time here in this case, you have to be careful. They only want up to the first 20 seconds, right? So therefore, this here is going to be 12 meters per second, right? You're not seeing the answer there, right? Hold on. Right, so the average speed here right is 240 over 20. That's the answer. Right, so that's number 8, right? This next one here, well, this one here is not my question, right? This is a previous CSEC question, right? So this one here is question 9. So question 9 in your exam is going to be based on circle geometry and some kind of trigonometry, right? So we have a diagram here. We have a circle and we have some lines inside the circle. So they said, given a reason, they want FAW. What is FAW? From the diagram, they want you to calculate FAW. That's this angle here, right? Now there are certain rules that we're going to have to use. So the line SW is a diameter. So that means that this whole angle here is going to be 90 degrees. That whole angle is 90. So therefore, to work out FAW, it's going to be 90 minus 54. You're going to get 36. Right? So that's the answer for that angle. Next thing we want to get is SKF. SKF is this angle here, right? SKF is that angle there. Now let me just erase something here. So this here is 36 degrees, right? All right, let's see. How we get to that angle there? Oh, okay. Right, so check this, right? So S, K, F, and E, right? Those are 4 points on the circumference of the circle. So therefore, that forms a cyclic quadrilateral, right? So therefore, this 54 and that angle there, SKF, those are supplementary angles, right? So opposite angles in a cyclic quadrilateral, they add up to 180. So therefore, to get SKF, it's simply going to be 180 minus the 54, right? And that's going to give me 126, right? This is going to be 126 degrees, right? And this third part here now, right? We want to get ASW. Where is that? ASW. Right? So ASW is this angle here, right? Now let me just clean up this. My suggestion to you all is when you're all working out a circle geometry question, right? Put in all the angles. Every time you work out an angle, just put the angle on your diagram, right? So this angle here is 126, right? So now we want to get ASW. That's this angle across here. All right, yeah, okay, so this one won't be too bad, right? So if this angle here is 62, right, it means that this angle here is also 62 degrees, right? Those are alternate angles, right? And I can only say that because this line is parallel to this line here, right? So if that's 62, then I can work out this angle here. So this ASW here, right, is simply going to be 180, right, minus, you have to add the 54, right, plus the 62, right, and you're gonna get 64, right? So this angle here is gonna be 64 degrees. So guys, for circle geometry, you all need to learn your rules, right? You need to learn your rules when it comes to this, right? Right, so usually question 9 we have circle geometry, and we may also have bearings as well, right? So I have a question here, right? The diagram shows the positions of 3 points A and B, ABC on a field, and the first thing we want to do, we want to show that the length BC, so you want to work out this length here, right? So if we look at this diagram here, right, clearly if you have two sides and the angle between them, we have to use the cosine rule. Right? Now I've taught my class when we use any cosine rule, don't just learn of the formula, understand exactly how we're going to use the formula. So in this case here, we're going to say BC squared, right, is equal to AT squared, right, plus 115 squared minus, open brackets, 2 by AT by 115 by cosine of the angle, which is going to be cosine 72. Right? So therefore BC squared is equal to, and I like to do this part by part, right? So AT squared is 6400 plus 115 squared, and that's 13225, minus, and we're working out everything there in the bracket. So that's 2 by AT by 115 multiplied by cosine 72, close brackets, and I'm getting 5686, right? So therefore BC squared is equal to right, I'm getting 13939, right, and therefore BC is equal to the square root of this. Right, and I'm getting about 118.1 meters, which is exactly what they told us to prove, right? That's what they told us to prove, 118.1. So that's correct, right? The next part, we want to calculate the angle ABC. So ABC, let me clean up this diagram a little bit. Right? Again, my suggestion is when you are calculating things, write it on the diagram. So this is 118.1 meters, right? And the angle that they want me to calculate here is this angle here, right? Now, what I'm going to use here, I'm going to use the sine rule in order to work this out here, right? Now, I use the sine rule only. I have an angle, and I know the length opposite that angle, right? I have this. Right, let me just write what it here. I don't know what happened there. Right, so this side opposite the 72 is 118.1, and I have this length and I have this angle opposite here. So I'm going to use the sine rule in order to do that. Again, how I've taught my class to do this is to know how to apply the sine rule, right? So to apply the sine rule, you're going to take a side and divide by sine of an angle. So let's say we start with the 115. So 115 divided by sine of ABC, which is what you want to find. ABC is equal to, we're going to take the 118.1 and divide that by sine 72. Right? So all I've done there is applied, right, my sine rule here. So to finish up the question, we're going to cross multiply. So we're going to say 118.1 multiplied by sine ABC, right, is equal to 115 multiplied by sine 72, right? So therefore sine ABC is equal to 115 multiplied by sine 72 all over 118.1. So therefore sine ABC right, I'm getting 0.926, right? So to get the angle ABC, that's going to be arc sine 0.926 and that's going to be 67.8. Right? So that's the angle here. This angle here, ABC, this one here is 67.8 degrees. Right? So whenever you get a bearing question, there's a good chance that we have to use sine as well as cosine rules in order to work it out. Right? Right, so that is part B, right? The next part of the question here, they tell us that the bearing of C from E is 147. So I'm going to clean up the diagram a little bit. Right, so the bearing of C from E is 147. So what that means is that this whole angle here, right, this whole angle there is 147, right? That whole angle is 147, right? So the question says, what is the bearing of E from B? What is the bearing of E from B? So the from is where we need to draw the north line. So you're going to draw a north line here, right? And we're trying to get to E. So the bearing that we're looking for, we need to get this angle here. That's the angle that we want, right? Now, we can do this in several different ways here, right? But let's choose the easiest way. So what you could do, you can work out this angle here, right? That small green angle there, we can work that out. That small angle there is going to be 147 minus 72, right? You're going to get 75. Right? So this angle here is 75 degrees. Now, if that angle is 75 degrees, I can work out this angle here because those two angles are co-interior. So this is going to be 180 minus 75. Which is 105. So this angle here is 105 degrees. Right? Therefore, if you want to get this bearing here, it's going to be 360 minus 105, and you're going to get 255, right? So this here is 255 degrees. That's your bearing. Then the second part, they want to know the bearing, right? Second part here, the bearing of B from C. Right? So the bearing of B from C. So what's happening here, you have to draw a north line by the from. This is C here. You need to draw a north line here. Right? And the bearing, so you're trying to get to B. So you're trying to come here. So we want this small little angle here, right? We want that small little angle there, right? All right, so what we're gonna do, we're gonna say this north line here is parallel to this north line here, and all we need to do, so we had worked out this angle up here, we got 67.8, right? Let me make sure I'm telling this correct, yeah? Okay, so I don't know if you're seeing it properly, right? I'm just going to expand it a little bit here, right? So this is the point C, right? And this is our north line. And I'm just going to exaggerate the diagram a little bit, right? So this is B. And this is your north line here, right? This is B, right? Now the angle that we're trying to work out is this angle here. That's what we want. That's the bearing of B from C, right? Now in terms of angles by B here, we know I could work this out here. I can work out this angle here, right? Now that angle there is going to be 105. So this angle is 105 degrees plus 67.8. That's 172.8 degrees, right? And now I'm going to use the fact that this angle and this angle are co-interior. So to get the answer that we're looking for, we just need to take 180 minus 172.8, right? And you're going to get about 7.2 degrees, right? Now, bearings questions are generally not as simple as we think it is, right? It requires a little more effort. So it's one of those harder questions, right? Somebody's asking if you can pass the exam with the SBA and the multiple choice and a few questions. Yes, you can, right? Yes, you can, right? All right, so last question here now. Question 10. So we know question 10 is based on vectors and matrices, right? So we have some vectors here, right? OA, OB, and OC express. All right, so if I were you, right, let's put a point O. Now it doesn't have to be accurate, it does not have to be accurate. This is just to help you visualize what's happening here, right? I'm just gonna put it here, so don't fault me and say, sir, you drew it wrong, right? I'm just drawing it here so you understand what's happening, right? So OB, you know what? There are some strange students out there. I'll put O here, right? 2 minus 2 is gonna be down here. 6, 1 is going to be up here, and 10, 4 is going to be up here, right? So this is 2 minus 2, this is A, this is B, and this is C, right? Like I said, some students kind of strange. All right, so these are my vectors here, OA, OB, and OC, right? The first thing they want the vector AB, so that's from here to here. So to get AB is going to be AO plus OB, right? Which is AO is going to be negative 2, 2. OB is 6, 1, right? So negative 2 plus 6 is going to give me 4, and 2 plus 1 is going to be 3, right? So that's the vector AB. Next thing we want to get is the vector AC. So you're going all here. So the vector AC is simply AO plus OC, right? In which case AO is the same minus 2, 2. And you're adding that to the vector OC, which is 10, 4. Right? Minus 2 plus 10 is going to give us 8. 4 plus 2 is going to give us 6. Right? So that's the vector AC. Next thing we want to do here, hence determine whether ABC are collinear. Whenever you all see the words collinear, collinear means that the points lie on the same straight line, right? So, based on my diagram, let's go back here. Yeah, so I have AB and I have AC. I have two vectors here. AB is 4, 3. So AB is 4, 3. Right? And AC is 8, 6. Right? So we want to determine whether A, B, and C are collinear, right? So let's say this is A, let's say this is B, and let's say this is C, right? What we're trying to do is to see if these 3 points are on the same straight line, right? That's something that CSEC likes to bring, and there are 2 things they're looking for in order for you to answer this question here. Now, we already have the vector AB, and we already have the vector AC, the full length here, right? So what I normally do, I normally start with the longer vector, which in this case is AC. So AC has to be written as K times AB. Let's see if that's true. So the vector AC is 8, 6, right? Now K, we don't know what it is, but AB is 4, 3, right? Now just by looking at these things here, we can say that K is equal to 2, right? K is equal to 2. If I multiply the vector AB by 2, I'm going to get the vector AC. So what that means is that AC is equal to 2 times the vector AB, which is this. Now, the fact that I proved that one vector, so this is what you need to see to get the answer, right, or to get the marks. So you're going to say since AC is a scalar multiple of AB, right? They are parallel, right? I want you to understand how CSEC marks this, right? This is a 1 mark for saying that, right? So once we are able to prove that one vector is a scalar multiple of the other, it means that they are parallel, right? We need to say one more thing in order to get a mark. You're going to say since AC and AB have the point A in common, right? That tells us that A, B, and C are collinear, right? This is what you need to see in order to get the marks, right? I see students struggle to answer a question like this, but there are 2 things we need to say. We need to prove that the vectors are a scalar multiple of each other, so they're parallel, right? And once they're parallel, we are able to, once they're parallel, right, it means that these 2 vectors are going to be collinear because they have a common point, right? So there are 2 things required here, right? 2 things required. Right, so let's move on here. Let's wrap this up quickly. Right, so we have determine the value of x for which a matrix is singular, right? So when they tell you a matrix is singular, it means that the determinant is equal to 0, right? So to work this out here, we're going to say 3 multiplied by 4 minus, right, x by 2, right? That's how we find determinant, but you're going to put that equal to 0 because it's a singular matrix, right? So that's 12 minus 2x is equal to 0, minus 2x is equal to 12. So therefore x is equal to 12 over minus 2. So therefore x is equal to minus 6, right? So make sure you understand what a singular matrix is. It's where the determinant is equal to 0, right? All right. NP are 2 by 2 matrices such that N is that and P is that. And so they want us to work out a product. So NP is equal to 4, 1, 3, 2, and you're multiplying by 1, 5, 2, 1, right? So this is matrix multiplication. So we need to multiply row by column, right? So you're going to take this row and multiply by this column first. So that's going to be 4 by 1 is 4, and 1 by 2 is 2. So that's 4 and 2, 6. So that's the first number in our matrix here. Then we're going to take this row and you're going to multiply by this column. So that's going to be 5 4s are 20 plus 1, that's 21. Then we're going to take this row now and multiply by this column. So that's 3 by 1 plus 2 by 2 is 4, so that's 7. And then for the last number, we take in this row, multiply by this column here. So that's 5 3s are 15 plus 2, that's 17, right? So that's my matrix product here, NP. All right, let me back up a sec. Somebody said the answer is minus 12 for which one? For this one? Oh yeah, let me back up here, guys, right? Let's go back here. See, that's why I need feedback. Yeah, when you move this here, this should be minus 12. So this is minus 12 here. So yeah, the answer for this one should have been 6, right? 6 or 12. Yeah, thanks for the correction. The answer is positive 6, not minus 6, right? So when you move the 12 on this side here, it becomes negative 6. Thanks for the correction, right? That's why I need feedback sometimes, right? Right? Let's see. Now they told us that Pn is given by this, right? Now we just worked out NP, right? And assuming that I worked it correct, 621, 717, right? So that was NP, right? But they told us that Pn is equal to this. Determine whether matrix multiplication is commutative, right? Now, what does commutative mean? If I told you that 3 by 2 is equal to 6, right? And I also told you that 2 by 3 is equal to 6 as well. The fact that we get the same answers tells us that multiplication, normal multiplication, is commutative. But when it comes to matrix multiplication, NP, we had a matrix, and they told us what Pn is, right? But those two matrices are not equal. So therefore, that tells us that matrix multiplication is not commutative. That's what it means, right? The fact that we're getting two different answers tells us that matrix multiplication is not commutative, right? Next part here, they want us to determine the inverse of n. So what is n again? N is 4132, right? So n is 4132. All right, so we want to get the inverse of the matrix. So the first thing we do, we find the determinant, right? So that's going to be 4 multiplied by 2 minus 1 by 3. So that's 4 2s are 8 minus 3. That's going to be 5, right? So that's the determinant. Now, to get the inverse of the matrix, all we do, it is equal to 1 over the determinant, which is 1/5. And we're going to write down what we call the adjoint of the matrix. So you need to swap the positions of the 2 and the 4. So put the 2 here, put the 4 here, put a minus 1 here, and put a negative 3 here, right? Now you can leave your answer like this if you want, or some students like to write in fractions. So this is 2/5, this is 1/5, negative 1/5, sorry, negative 3/5, and 4/5, right? So this here represents my inverse matrix, right? That's the inverse matrix. Right? And the final part here, final part, hence calculate the values of x and y, right? Now, what they're doing here is asking us about, this is a CSEC question, right? This is not mine. They're asking us about a simultaneous equation in SMART here, right? So what they've done here, they've actually written it in a format that we would have done if we were solving a pair of simultaneous equations, right? So the equations would have been 4x plus y is equal to 1, and the second equation would have been 3x plus 2y is equal to 2, right? So they could have given us this and tell us to solve this, right? But they kind of jumped this step for us. And what we just worked out, we worked out the inverse of this matrix here. So when you have to solve a pair of simultaneous equations, we would have had to find the inverse of this, which we already did, and multiply both sides of the equations by the inverse. So this would have been 1/5 multiplied by, this would have been 2, 4, minus 1, minus 3, right? Multiplied by 4, 1, 3, 2, xy, right? On the right hand side here, what I normally tell students to do, leave it in the fraction format, right? I don't like students when they work in a simultaneous equation to work with this. It makes it more difficult, right? So don't do that. Stick to this format here instead, right? So this is 2 minus 1 minus 3, 4, and you're multiplying that by 1, 2, right? Now, when you work this out here, you're going to get your identity matrix. So on the left hand side, everything disappears except this, right? And this here is going to be 1/5. Now, 2 by 1, I'm just multiplying this matrix here by this here. So 2 by 1 is 2, right? And 1 by minus 1 by 2 is minus 1. So this is going to be 0. And then minus 3 plus 8 is going to give us 5. So therefore, xy is going to be 0, 1, right? So that tells me that x is 1 and x is 0 and y is equal to 1, right? All right, guys, so that brings us to the end of my sample paper, right? I'm going to repeat this again, right? I'm going to repeat this again. This is not the paper that is coming tomorrow, right? I see everybody asking about a leak paper. I will never leak any exam, right? So in this case here, this is just a sample paper, right? It has 10 questions, right? Typical examination questions that we could get in the exam. So what I need you all to do is this is my advice to you all, read your questions carefully, right? Your biggest problem in that paper is going to be time. The time may seem like a lot, but it is a very short time to try to do 10 questions, right? Now, guys, in terms of the exam, the order in which you do the questions, you can do the questions in any order that you want, right? And my suggestion to you is do all of the easy questions first. So do the topics that you are comfortable with, right? Do the topics that you are comfortable with, right? So don't rush to do question 10 first. Question 10 is something I will do last, right? That's something that I would do last in the paper, right? So read your questions carefully. Try to put as much work in as possible, right? I know some people like to do things in the calculator and just write down their answer, but try to show as much work in as you can, right? Guys, good luck in that exam tomorrow, right? I wish everybody success, right? But that's it for me for this afternoon, right? Enjoy the rest of your night and enjoy your last minute studying, right? And take care, everybody. Good night.